So our next lesson is a study of reactivity in organic chemistry. Reactivity. Reactivity in organic chemistry. Reactivity. That's lesson 6. In organic chemistry, we're going to have 3 main types of species: a carbocation, a carbanion, and a free radical. So, an organic compound, first of all, there are in 2 main groups. There are saturated compound, there are unsaturated compound. So, the study of reactivity depends on many factors such as steric hindrance, the solvent effect. So, these are the 2 main factors that influence the reactivity in organic chemistry. So, what, first of all, is a carbocation? What is a carbanion? What is a free radical? So, it's a carbocation. Carbo. A carbocation is simply a positively charged carbon. So we can denote a carbocation as C plus. A carbanion is a negatively charged carbon. In organic chemistry is denoted like that. C minus. A radical is denoted as R dot. R is an alkyl group. So furthermore, we can group these species into 2 main groups: electrophile and nucleophiles. So, what's an electrophile? What's a nucleophile? So we can see electrophiles nucleophiles. An electrophile is an electron deficient species that react by accepting electrons. A nucleophile is an electron rich species that react by donating electrons. In organic chemistry, an electrophile is denoted as E plus, while a nucleophile is denoted as E minus. An electrophile is an electron loving species. So electrophile will love electrons because it's positively charged. Electrons are negatively charged. Nucleophiles are electron rich species. In that case, they will love the nucleus. So they are nucleus lover. The nucleus is positively charged. Okay, let's see how we can study the reactivity of this were the reagent. Then what about this were the reagent? Okay. What about the species or the reactant reacting themselves? Okay. Let's see how reactivity influence the reactant. There is what we call steric hindrance. So consider these organic compounds on the board: CH3C, CH3, CH3, Br, CH3, Br. What are the 2 compounds on the board? One will react more faster compared to the other due to the what we call in chemistry steric hindrance. The steric hindrance now is the number of alkyl group that surround the alpha carbon. In this case, this compound, I'll say compound A, compound B. Compound A has more steric hindrance than compound B because of the number of alkyl groups. So these alkyl groups will reduce the reactivity of the organic compound compared to this other compound. Okay, whereas what we also call inductive effect. So the inductive effect will have inductive effect. That species that are positive inductive effect, that species that are acting as negative inductive effect, that donors of electron and that withdrawers of electron also. So we can have these two compounds also. Let me write two compounds on the board. CH, CH3, CH3. I have also CH3, CH2, CH3. So the methyl groups, they are positive inductive effect, meaning they are donors of electron. They increase the reactivity. We can have also electron withdrawing species. So most of this stuff is still university. Organic chemistry advanced level is just introduction to organic chemistry. So in our next video, we're going to see the reaction mechanisms. But the reaction mechanism will be seen when we're treating the various homologous series. Like the alkanes will see their own way of reacting. The alkenes will see their own way of reacting. So this was just an introduction to the chemistry of the functional group, which is alkanes, alkenes, alkynes. So that when I'm going to quote a word, it should not be lost. When I'll say a carbocation, you know what it means. When I'll say a carbanion, you know what it means. When I'll say an electrophile, a nucleophile, inductive effect, mesomeric effect, you know what it means. Even though when we're treating the homologous series, I will be emphasizing on those terms. Okay, thank you for watching. Follow me on ATQs.